Hello, in this short video we are going to investigate the following challenging problem on the topic of evaluating definite integrals. If the definite integral, as you see here, is expressed as this expression e to the power of pi over a times b e to the power of pi over c minus 1, then b squared c over a is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer to the problem. Okay, so this is our problem. This integral is given to be like this. Of course, we don't know a, we don't know b, we don't know c. By calculating the left side integral and equate it with this expression, in principle, we will be able to read the values of a, b, and c. And when we have them, the question is asking you about this combination between this combination for a, b, and c. Okay, so what we do, let me call this integral I. I will call this integral I, and then I start simplifying this integral a little bit. So I would write it from pi over 4 to pi over 3. I write e to the x, but in the denominator I use the very famous formula that 1 plus cosine 2x can be written as 2 cosine x squared. And in the numerator I write 2 plus, I use the double angle formula for sine, so it becomes 2 sine x cosine x, and then I have dx. Now what I will do, I will separate this fraction into two fractions. So integral from pi over 4 to pi over 3 e to the power of x. Then I decompose my fraction into two fractions, 2 over 2 cosine x squared plus 2 sine x cosine x over 2 cosine x squared, and then totally dx. Yes? So now what happens, first of all, you see that this 2 and that 2 are cancelled, this 2 and that 2 are cancelled, and I want to decompose my integral by multiplying this e to the power of x here and e to the power of x there, and decompose one integral into the sum of two integrals. Okay, so I'm going to do that. So this becomes integral from pi over 4 to pi over 3 e to the power of x times 1 over cosine x squared dx plus integral from pi over 4 to pi over 3 e to the x. But now look what happens. One cosine and one cosine is also cancelled, and I have sine x over cosine x, which can be written as tangent x dx. Okay, now what I want to do, I want to use the method of integration by parts on the first integral, but I will not touch the second one. You will see why. So what I want to do, I want to call this one dv, and I want to call this one u. Okay, so u is equal to e to the x, so dx, du becomes e to the x dx, and I have 1 over cosine x squared, dx is my dv, so one possible choice for v is tangent x, yes? Because the derivative of tangent is just simply 1 over cosine x squared. So, if you don't mind, let me call this integral I, let me call this integral j because I have already used letter I, and let me call this integral k, okay? So now I know that the integral I that I want to calculate is just j plus k. But let us concentrate on calculating only j using integration by parts. So the answer becomes uv from pi over 4 to pi over 3 minus integral from pi over 4 to pi over 3 v du. Yes, this is the standard formula for integration by parts. Integral u dv is uv minus integral of the other way around, v du. So what is uv? So u is e to the power of x, v is tangent x. This is supposed to go from pi over 4 to pi over 3 minus integral from pi over 4 to pi over 3 v du. But v is tan x, du is e to the x dx. Now you see something interesting happens. So what is the name of this integral? That is exactly integral k. But the good news is that here k appears with negative sign, here k appears with positive sign. So let me continue. So the first part can be calculated easily. So it is e to the power of pi over 3 tangent pi over 3 minus e to the power of pi over 4 tangent pi over 4 minus k. So this is my j. Okay? But I can simplify this a little bit because I can write e to the power of pi over 3. Tangent of pi over 3 is just simply a square root of 3 minus e to the power of pi over 4. Tangent of pi over 4 is simply 1 minus k. So the integral that I am looking for is j plus k, which becomes e square root of 3 e to the power of pi over 3 minus e to the power of pi over 4. Okay, so that is my integral. But I have to write this answer in a way that I can compare it here. So what you see that I want to have this one equal to 1. So I will factor this out. So this becomes e to the power of pi over 4 square root of 3 e to the power of pi over 3 divided by e to the power of pi over 4, it simply becomes e to the power of pi over 12, yes, minus 1. Yes, so we can double check. If I multiply this back here, pi over 4 plus pi over 12 becomes 4 pi over 12, which is pi over 3, so that is correct. And when I multiply this here, that's also correct. Now, if you compare this final answer with this answer, you can immediately read A, B, and C. So, what is A? A is 4, B is square root of 3, and C is 12. But the question mark is B squared times C over A. B squared becomes 3 times C, which is 12, divided by 4. So this becomes 36 over 4, which is 9. So the answer to the problem is 9. So this means that option C is the correct answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.